Hello, everyone, and welcome to our session today on source control best practices. Joining us today is Daniel Palmer and Bryce Menadue, both from Innovia Consulting, and we're excited to have such a fantastic turnout today. Before I pass it over to Daniel and Bryce to cover on this hot topic, I would like to remind you that this session is being recorded and it will be posted to our on-demand webinar library later this week for you to review and share with anyone. And if you have any questions, please feel free to type them into the questions box. We will get them answered during our Q&A time at the end of our session. So now I will pass it over to Daniel to kick off our presentation.
Great, thanks Angie. So my name is Daniel Palmer. Joining me today is Bryce Menadue. We are both developers at Innovia. I've been working with Innovia for a little over 2 years. Bryce, I think you just had your 1 year. So we're got a couple years of experience between us working on source control and development, kind of nailing down the best practices on how to track these changes. For today, I'm going to begin with a source control discussion, general best practices, and going to discuss it from a conceptual standpoint. I'll hand it off to Bryce, and he is going to run through a demonstration of the actual implementation of these best practices. The first thing to think about is the 3 different databases you have and how these tie into your source control. So if you, as a client, and your partner both have separate development databases, if you're both doing development and you're not sharing a development database, you need to consider differences between these development databases when you're working on them. So our procedure, if you have separate databases, is to begin development by locking the object in both the development and the test databases. You want to refresh the relevant objects in your development database with the test version. So what that means is that if your partner has made changes to a certain set of objects and moved them into the test database, and you make a different modification in your separate development database, moving those changes forward blindly will overwrite somebody else's work. So that's the first thing to keep in mind, is whether you have a shared development database or separate development databases. If you do share a development database, you don't need to worry about that step. So where source control comes into this is when you want to move changes into source control. So what we do at Innovia is when we move changes from the development database into the test database, that's when we check our changes into source control. So what that means is that your source control is always going to be a copy of test. There's another method you can use, which is checking these changes in when you move the objects into live. Now, the advantage to that is your source control is going to track the history of the live database. The disadvantage to that is you won't really be tracking in-progress modifications. You're only going to track the history of things that are actually in your live database. I would definitely recommend that you track in-progress modifications, and if you feel like you need a history of your live database alone, I would recommend that you track both the test and the live databases in source control. Tracking both live and test is going to add a little bit of overhead for your developers, but if you want to track the live database, I think it makes a lot of sense. I switched slides there. I think it makes a lot of sense to also track test. So if you're going to do live, do test as well. I personally think tracking the test database is sufficient, but that's really a discussion that you'll need to have and decide which point you want to move these changes into source control. So the actual process for moving modifications into source control, you'll want to create a new branch for each modification you make. Now, the advantage to that is it facilitates rollbacks. You can easily see which changes, which objects are involved with which modifications, and it keeps your source control kind of neat and tidy. So creating a new branch, you can think of that as a working copy of the test. I'm going to use the test branch as an example. So you'll create a branch off of the test database in source control, and that'll be used until you're complete with your changes, at which point you'll check that back into the test database in source control. So you will create that branch. You will make your changes in the development environment after locking those objects. So you'll lock them in the development database, and if you're working in separate development databases, you'll want to lock that object in test as well. Once you're done with your changes, you will move them into the test database. So you'll move those objects from the development to the test database. You'll update the ticket branch that you created in the first step, and you will check that ticket branch into your test source control. When you're checking objects in, you'll want to add a concise check-in message, but make sure it's at least somewhat descriptive. You'll want to, the more descriptive it can be, the better off you are when reviewing the history of these objects. So if you have any type of internal ticketing system to track modification requests, or a lot of times you can use the subject of an email, things like that, just to make sure that when you're reviewing the history of your objects, you can track what exactly spawned that change. So what influenced you to make that change, so you can keep everything together. And then once you are complete with your testing, you will move those objects into live, and you will merge your ticket branch into the live source control. And then also check that change into the live source control. So that last step is really only if you are tracking test and live source control. If you're just doing test, when you move the object from test into live, you don't need to update the source control. So that's just if you want a little bit more comprehensive histories of your two databases instead of just the test database. So at this point, I will hand this off to Bryce, and he will discuss our live demonstration.
Perfect. Thank you, Daniel. Good afternoon, everyone. My name is Bryce. I'm also a developer consultant at Innovia Consulting, and today we're going to show you a little bit of the basics on how to get into using Git, specifically with Azure DevOps and VS Code. Now, depending on your organizer, they may or may not have already set up a repository for you to use. In my case, we have a repository to use. So the first step will be cloning that repository onto your local machine. And we can do that by going ahead and opening up Visual Studio Code. And from here, we'll go to our command palette, either View Command Palette or Control-Shift-P. And Git is already baked into VS Code, so we shouldn't have to worry about any of the tools not being there. In this case, we're going to go ahead and click our Git Clone button, and it's going to ask for URL. Now, depending on the hosting, whether GitHub, Bitbucket, or Azure DevOps, they should always give you a URL to clone this repository. In my case scenario, I have the URL on hand. I'm going to copy that to my clipboard and paste it in, and then press Enter to begin cloning the repository. Now, immediately it's going to prompt you where you want to put this folder. In my case scenario, we're going to go to my documents, and I'm going to put this in my Git folder. Select the repository location, and in the bottom right, you'll see a notification letting you know that it's working. And it's all done. We're going to disregard this notification. And now I can navigate to the extension that I want to work on. I'm going to go ahead and open folder, and we'll go to the extension that I want to work on today. select that folder, let VS Code catch up. And now things are starting to look familiar. You can see your files, your AL packages folder, your VS Code folder, so on. Something changed though. In the bottom left of the screen, you'll notice that the word master is there. Now, that's going to indicate what branch you're currently working in. So in this case, I'm working in the master branch. Nothing wrong with that as long as you're working by yourself. So I'm going to sit down today and I'm going to begin work. And let's say that I want to clean up some of the comments in my code. So we'll go ahead and make some changes. And one last one. Control S to save real quick. And now on the left side of the screen, you'll notice under my source control menu, there's a little 1 indicating 1 pending change. Clicking on that menu, now I can see the entire list of changes that I have thus far. For this example, only changed 1 file, and you'll see the little M next to that file indicating that it was modified. There's a whole list of other icons, including an added, deleted, updated, etc. In this case, we only modified the file, but let's say I want to see exactly what I modified. By clicking on that file, now I can see a side-by-side comparison of what was there previous on the left, and then on the right, what's going to be going into source control. Now this all looks good to me. Now the first thing in a Git Flow is going to be to stage the changes. So in VS Code, we can do this all from the text editor. We can click on this little plus that indicates to stage the change. Now the next step in Git practices are to commit the changes. Every commit's going to require a message. So in this case, we will say that this was ticket 101, development effort complete. Looks good to me. Now we can go ahead and commit these changes. Little loading indication to let you know it's working. Now there's one final step we're going to have to do before these changes are actually up in our cloud source control. Going over to the 3 dots next to the source control title, I'm going to click on that and get a whole list of options. What we're concerned about right now is actually pushing these changes up to the repository. So either clicking push or Control-Alt-U, another little loading indicator, letting you know it's working. And if I go to my repository, in this case Azure DevOps, and I go to the file contents, I can see that my customer card extension was updated just now. Now Azure DevOps is very helpful in the way that I can actually go to this file and not only can I see the contents of this file, but I can actually look at the history of this file. So I can see that in my commit with the message of ticket 101 development effort complete, just now, I can click on that and it'll bring me up a side-by-side comparison of exactly what was changed. Now this might all sound well if you're working by yourself. However, we'll get into that branching that Daniel mentioned earlier. So to follow a proper practice, and this is only one of Git's many flows, and depending on your organization, you may want to determine rules on how to go about some of these things. Let's say I'm a developer and I have counterparts within my team, but I need to do work specifically pertaining to a new ticket that came in. So from Visual Studio Code, if we go back down to the bottom left and identify what branch you're in this case master, and I click on that, I'm going to get a new prompt at the top of the screen. I'm going to get the options of create a new branch or create a branch from. Since we're already trying to branch off of master, master being the most up-to-date, the working code, we're going to just create a new branch right away. We're going to type in the branch name. To keep it organized, we'll call it ticket 102 and press enter. Another loading in the top left. And you can see now in the bottom left, it's letting me know that I'm in branch ticket 102. Now let's say this ticket calls for an extension on the item table. We can go ahead and do our work. Say we need to add an extension onto the item table. Call it item extension, excuse me, type in the ID first, 50,000. Item extension, extending the item table, and we just need to add a single field. Call this field 50,000. New field, and we'll make it a text. Perfect. My work for the day is done. This ticket is complete. It has been tested, and all is well. We go back to the left side of the screen, and we can see the new one pending change from our source control menu. Now the one is only indicating that there was one file changed. So the more files you change or modify or update, that one could turn into 2, 3, 4, 5, etc. Anyway, we're going to continue with the previous flow, and we're going to stage our changes. We'll enter in our message, ticket 102, dev effort complete. And we're going to go ahead and commit these changes. Once it's committed, then I can push the changes from my local machine up to the repository. And now this pop-up is going to happen every time you create a new branch. Since the repository has no idea what ticket 102 branch is, we're going to have to publish this branch in the first time. Now, say you're working your branch for multiple days, this pop-up should only happen the first time, since the repository then knows what the branch is. So we'll click OK. A little more loading in the top left. Perfect. Now we can go back to our Azure DevOps, and conveniently on the left side, we can navigate to our branches menu. And now this page is going to show us all of the active branches that this repository currently has. In this case, we have the master branch and the ticket branch. And going into the ticket branch, we can see that my item table extension is here. Switching back to the master branch, we'll see that it is not there. This will help in eliminating confusion from developer to developer working on different tasks at the same time. Now we reached the point of done, however you want to define done, whether it's testing, user says it looks good. We want to make sure that all of my changes in this ticket 102 branch are now in the master branch so that other developers have that code and they're not wondering if a certain ID is taken, if the field has been added or not. So luckily, in Azure DevOps, there is a way to do that. Going back to the branches menu, we'd like to merge ticket 102 into the master. And now rather than just immediately merging the changes, Azure DevOps has put in another door you have to go through. You'll notice when hovering over this branch, a new button pops up, this new pull request. Now when I click that, it's going to give me a form to fill out. In this case, it's going to automatically populate some of the fields based on commit messages and titles. Starting at the top, it's going to make sure that you want to merge ticket 102 branch into the master branch. Title automatically filled with the recent commit message, description as well. Scrolling further down, depending on your organization, you can assign reviewers that you'd like to review the code or the pull request, the changes being merged. In this case, we're not going to attach any reviewers. And then depending on your organization as well, you can attach a work item. These items will be directly pulled from your Azure DevOps board, whether it's a sprint task or a sprint story, you can assign them here for better navigating through the history of your source control. Going past the create button, we can now see all the files and the commits that were associated with this branch. In my case, there's only been a single file and one commit. Well, this all looks good to me. We're going to go ahead and create. Now we can see that the pull request has been created. Starting at the top, the number 23 just indicates what number pull request this has been. In my case, 23. It's currently active. The title, the author, what's trying to be achieved, and it defaults to the overview tab. Now, let's say I'm another developer that's going to be reviewing this. I can come into this pull request through the pull request menu of the repository, and I can see all the files that are being added, every line of code. I can see all the updates, and I can see all the commits, along with author and timestamps associated. Now, if we were to have a reviewer, that reviewer has a few options. They can approve immediately. They can approve with suggestions, maybe use a case statement instead of an if statement, but still looks good, can wait through the author, or reject the pull request. This is not complete. We're going to go ahead and approve it right away. Okay, it was approved by myself. And then we can go ahead and complete the merge. Another pop-up will come up, letting you know that this merge is going to happen. We're just going to merge right away. And then depending on the organization as well, you may want to hold on to that branch, or you may want to delete it. In our case, I don't see any reason to hold on to the old branch, as this was fully tested and the customer likes it. So we have no reason to hold on to the old code. Excuse me, old branch. So we're going to go ahead and complete the merge. Let DevOps catch up. And now it was completed. So who did it, when they did it, and what they did. Now, as my counterpart sits down for the morning, saying he's not in a current branch, he's going to be in his master branch. But when he looks at his File Explorer view in VS Code, he's going to see that that new file is not there yet. Now, to make sure that he has the most recent changes, each morning I would recommend personally to go to your source control menu and do a pull from the branch that you'd like to pull from. In this case, he wants to pull master because that's going to be the most up-to-date, fully trusted code. And we're going to do a pull, do a little bit of loading, and then navigating back to the File Explorer, we can now see the item file is there. And that will conclude the demo. Some things we covered today is the basics of Git in VS Code and in pair with Azure DevOps, including staging and committing your changes, the acts of pushing and pulling changes, and then branching and merging with VS Code and Azure DevOps. And at this time, I'd like to open up the floor to any questions.
All right. What made you decide Azure Development Ops over GitHub?
I'll take this one, Daniel. I think being an all Microsoft house, I think Azure DevOps was the appropriate tool. Not to neglect GitHub. GitHub is a very useful tool, and I've used it in the past between school and personal use, but I think Azure DevOps was what we had in mind because it also handles all of our project management side of things where we can assign tasks and it's all tied in through a single Office 365 account. So the author, the email, who is assigning work, and then the repositories, it's all within one URL.
All right. Thank you very much, Bryce, for that. Any other questions before we wrap up? All right, I don't see any more coming through. So we do have a few more webinars coming soon. Tomorrow, Thursday, August 8th, we have Ross Bottorff from Innovia Consulting, and he's going to be presenting on add item tracking lines using Nav Business Central Web Services. And then next Tuesday, the 13th, we have Notice presenting on payment processing and customer payment portal for Business Central. So check out our website for more of our upcoming events, and that's innovia.com/events. And we also want to mention that we do have our podcast that is airing. It's called the Innovia Conversation, and you can find out about all the different podcast platforms that you can listen to on our podcast page, and that's innovia.com/podcast. So check those out and subscribe so that you get notified on all of our new episodes. And Innovia is proud to be a platinum sponsor of BCUG NAVUG Summit in Orlando, Florida this year. And that's going to be October 13th through the 18th. And if you haven't already registered or you want more information about Summit, check out our conference page on our website, and that's innovia.com/conferences. All right, thank you again for joining us, and we look forward to seeing you again soon on another Innovia webinar. Have a great day, everyone.